Hi everyone, welcome to the channel. This is Fahad Mirza. Yesterday, I received an email from a very long time viewer, and he said that he has been trying to get an AI job for some time now, and he has interviewed in Nvidia, in Google, in Amazon, and few other very well known names. And he compiled a list of concepts and questions which he was asked for in during those interviews, and he wanted me to create a video explaining all of those terms in simple languages so that the people who are looking to get a beginner level job or even an intermediate or expert level job in AI or LLM engineering should be able to give some satisfactory answers. And this video is specially focused on those people who doesn't have any PhD in LLM engineering or AI, who doesn't have even a university degree in AI, who are just people either coming from an cloud background, database background, coding background, and so on and so forth. And they just want to transition to any LLM engineer, AI engineer, or even machine learning engineer's job. This video is by no means an exhaustive list of interview questions you are going to be asked in your interview, wherever that is. The purpose of this video is to give you a flavor of what sort of preparation you need to make if you are going for such an interview. Now, I haven't compiled this list, I have just received it, and I think it's a good idea because I have been asked the similar questions in a lot of videos in the last few months as how to get a job as an AI engineer. So let's get started. The first and foremost thing you need to be aware of is that this is an exciting journey in the field of AI. There is no time like this before, and it is essential to understand the fundamentals and latest advancements in the field. So, first, of course, you need to know what exactly is AI. AI refers to the development of computer software systems or even hardware that can perform tasks that typically require human intelligence, such as learning, problem solving, reasoning, perception, and language understanding. These artificially intelligent systems have transformed and still transforming industries from healthcare to finance to transportation and education, and have opened up new avenues for innovation and growth. As an aspiring AI engineer, you are about to join a rapidly evolving field that's shaping the future of technology. In order to be successful in this field, you will need to understand the underlying concepts, architectures, and techniques that power AI systems. So, we are going to delve into the key concepts and questions that are commonly asked, which I just mentioned earlier. I'm also going to explore a bit of intricacies of these topics, discuss real world applications, and I will try my best to provide you valuable insights to help you prepare for your interviews. Now, first thing you need to drill into your mind that we are working on bleeding edge. You see me creating videos every day on different topics from LLM installations to new tools to new research papers to new frameworks about some new innovation, about some hosted APIs, about some local stuff, fine tuning, training, and the list goes on and on and on. Sometimes I say one day that this is the best model. Just after 2 to 3 days, I say that no, this one is not the best model. And that seems like a never ending loop. So this means that we are working at bleeding edge. You see that whenever I release a video about a tool, there are many questions around people facing a lot of issues because things are evolving so fast. Maybe your software configuration is different, your hardware configuration is different, or maybe just in 2 to 3 days, the software has changed. Maybe the repo of that tool has changed because those people are also evolving and creating. So we are working on bleeding edge, understand that. So whenever we are working on the bleeding edge, this is just the um, game we need to play. So let's get started. I'm just going to take you through. Now, one thing, And this is, I'm telling you from experience. Don't think that anything is obsolete. Don't think that if you are coming from, let's say, cloud background, from programming background, from databases background, from project management background in IT, or from any other IT related field, it doesn't mean that your skills are obsolete. None at all. If you are following my channel, you know that on daily basis, whenever I am showing you something I am working with operating systems, whether it is Linux or Windows. I know mainly Linux. And I am working with databases, whether they are relational databases or vector databases. No, sorry, no SQL databases. I'm working with lot of Python, lot of Node.js, and JavaScript. We are working with web technologies. We are working with web frameworks. So, and of course, we are working with networking concepts. We are working with cloud concepts. So nothing is obsolete. Trust me, if you have experience in these fields, that is a gold. You already have a head start. And if you don't have it, still don't worry. And I will tell you why you need not to worry, even if you're a beginner later in the video. So stay tuned. Okay, so let's start with these concepts. First, of course, you would need to lay the foundation around this. When I say lay the foundation, you need to be aware of the architectural and all the foundational concepts, which starts from transformer. And there are a lot of architectures around LLMs like RNN, CNNs, but just understand mainly what is transformer. So the transformer architecture has really changed the way we think about AI because it introduced something called as self-attention mechanism. This allows these LLMs or large language models or simply foundational models or models to weigh the importance of different input elements, enabling parallel processing and improved performance. Unlike the previous recurrent neural networks or RNNs, transformers don't require sequential processing, making them more efficient for long range dependencies, and we have seen a lot of advancements there. Then you need to know about what is the difference between pre-training or simply training and fine-tuning. Pre-training involves training a model on large general data set like the entire Wikipedia data. This provides a strong foundation for understanding language. Fine-tuning then adapts the pre-trained model to a specific task or data set that achieves better performance. This two-stage approach enables us to leverage the knowledge gained from pre-training and tailor it to our specific needs. It is quite useful when working with limited task specific data. Then, what are the training objective? Look, next token prediction is a crucial training objective. By predicting the next token in a sequence, the model learns to understand context, syntax, and semantics. This enables text generation and completion capabilities. There are other objectives too, like masked language modeling, also contribute to the model's overall language understanding, or it could be around diffusion models for text to image generation, or TTS model, or STT model, and the list goes on and on. But these are the major ones. Then we have a question around context window, and that is one of the most popular question. Context window limits the input length the model processes. This is a spotlight which model throws on a data at a given point in time. This is very important due to computational constraints. Positional embeddings help the model understand the input sequence structure, which capture relative positions and relationships. We have techniques like sliding window or chunking, which can help process longer sequences. Then you need to know what is tokenization and what are tokenization strategies. Tokenization breaks the text into smaller units. Word level tokenization is simple but may not really capture sub-word nuances. Sub-word level tokenization like word piece or BPE represents words as composition of subwords, which hand out vocabulary words better. Character level tokenization is useful for language with complex writing systems. So tokenization simply converts your text into a format which LLMs understand. Then you need to be aware of what sort of model scaling laws are there. Like model scaling laws describe how performance improves with increasing size and compute resources. These laws guide scaling decisions that ensures efficient use of resources. Then we have parameter efficient fine tuning, which introduces techniques like LoRa, QLoRa, and prefix tuning that update specific model parameters for fine tuning that reduces computational cost. This is quite useful when working with LLMs or limited resources. By adapting only a subset of parameters, we can achieve impressive performance gains without significant computational overhead. Then you need to be aware of how you can control the output generation of model. So you have something like temperature and top piece sampling. Temperature controls the randomness of text generation or responses of LLMs. Higher temperature introduces more randomness, while lower temperature produces more deterministic output. Top piece sampling selects the top probabilities that influences output diversity. By adjusting these parameters, we can balance creativity and coherence in generated text. So you should also be learning about top P, top K, and then there are few others. So just pick up few hyperparameters and that should be good enough. Prompt engineering is important, which primarily designs effective input prompts to get desired responses. This involves understanding the task, the model's capabilities, and the context, and make sure that you are aware of what sort of prompt template model supports, and there are a lot of them which you should be aware of. Then you should be knowing about what is zero shot learning, few shot learning. For example, few shot learning means that it trains the model with a few examples, adapting to new tasks quickly. This capability enables the model to learn from limited data, making it more versatile, and by providing a few examples, we can guide the model's behavior and improve performance. Then we have something called as in-context learning that provides context within the input prompt, and that enables the model to learn from it. And this approach allows the model to adapt to new tasks or domains without requiring extensive retraining. Then we have something called chain of thought. Chain of thought encourages the model to generate intermediate reasoning steps before producing the final output. This provides insights into the model's thought process and can improve output quality by breaking down complex tasks. And then hallucination is something where model gives uh, inaccurate or not factual responses. So we need to come up with some hallucination prevention technique, which could be fact checking, judge LLM, source attribution, or even simply limiting the model's output length. Now, next one is LLM evaluation. There are a lot of stuff there. You need to be aware of what is perplexity. Perplexity measures the model confidence in its prediction. Low perplexity indicates better performance, but perplexity only evaluates the model's probability distribution, not its actual output quality. So it's not that you used commonly. Then we have Roach scores. They are quite common. It evaluates text generation quality by comparing overlap with reference text, and this help assess the model's ability to generate relevant and coherent text. Then we have Blue scores, and this measures the similarity between generated and reference text. While useful, it has its limitation, and I really haven't seen it being used that much lately. Human evaluations are also there, where it there are human assessors evaluating the model's output and then marking which one is better and which one is not. Then there are a lot of benchmark data set around MMLU, Big Bench, Human Eval, and then Math Eval, and you can search my channel. I already have done an exclusive video on these benchmarks. Now, there are a lot of other things. For example, if I say we can go with bias detection, where it identifies and measures biases present in model output. This involves analyzing the model's performance across different demographics, topics, or perspectives. It could involve technique like data augmentation, adversarial training, and debiasing methods. Then we have optimization and deployment. Now here we have something called as quantization that reduces models precision like 4-bit, 8-bit, and even now we have ternary LLMs for faster inference and reduced memory usage. This is quite useful for edge devices or resource constrained environments. You need to know about a lot of quantization technique like quantization aware technique, and then I have done various videos on it. Just search with quantization and you will find a lot of them. Model distillation concept is important. So what model distillation does, it transfers the knowledge from a teacher model to student model, or in other words, larger model to smaller ones. This technique enables deployment of efficient models while preserving performance, and it involves training a smaller student model to mimic the behavior of a larger teacher model. Okay, and then we have a lot of other things. For example, you should be aware of prompt caching, which is used for faster retrieval. We have model merging, where I have done a lot of model merging technique videos. Just search with model merging, and this technique primarily again reduces computational overhead and can also improve the performance in some cases, but not always. Then there are few ways of, and optimizing inference, which includes like pruning, knowledge distillation, compiler optimization, and some prompt engineering. Then load balancing is quite important. You should be aware of cloud load balancers such as, or non-cloud ones like Nginx and a lot of others. Latency is quite important. You should be aware of how can you reduce the latency. Techniques like caching, parallel processing, async processing, and then I have done some videos. So all of these topics, also I will suggest that searching my channel with all of these separate topics, and you should find a lot of videos around it. And then cost optimization, that is very near to my heart. I believe, you know even if it is AI, even if it is expensive, there are a lot of ways of FinOps in terms of AI where you can save a lot of cost. I have done various videos on AI cost optimization, so please search it out. You won't regret it. One thing I would highly recommend you is that this must not be an afterthought. As soon as you have started implementing AI in your personal or in your company's arena, think about cost from the day one. You will thank me later. Safety and ethics, make sure that you are aware of it. So this involves a lot of things: content filtering, output sanitization. Just make sure that you don't include any harmful or unwanted content, and keyword filtering, sentiment analysis, natural language processing should be there. Everyone should ensure a safe and respectful user experience. And for sensitive data, data masking, anonymization, entity recognition, data reduction should be there. So sanitization should ensure protection of sensitive data and maintain the user trust. Jailbreak prevention techniques should be there, which should be preventing the malicious users from manipulating the model. That is why I don't use PT format, always use safe tensors. Data privacy should also always be there, and that is for, it's really essential for maintaining trust and ensuring ethical AI development. Now, this is what I was referring to when I said that even if you're a beginner, if you don't know about IT, just starting out, don't get overwhelmed. Remember that expert of today is beginner of tomorrow. Just couple of years back, I had no clue about all of these LLMs. Nobody had. Trust me. Um, I think only AI PhDs or select few had some clue, but over, I think, 99.99% of the world had no clue. We were all beginners. I still am. I'm a big beginner, but the people who are expert today of AI, they are beginner of whatever is coming tomorrow. So we are all are in the same boat. We are all learning. We are all working on bleeding edge. Yes, you might take bit of a time if you are just starting out about the basic concepts, but if you persevere, if you keep working hard, if you keep learning, you will get there. Trust me. This is the beauty of our IT field. I mean, I started as a database administrator long time back, and then when I was working in databases, cloud came. And when I first looked at the managed database offering, I knew that I would soon become obsolete. I will be a dinosaur. So I reinvented myself. I taught myself cloud around, I think, 9 years ago. And then I started working in cloud. When AI came, all of this generative AI, I knew that I have to reinvent myself. I only had encountered AI some when I was in my uni. That was long time back, and I had the major in AI. But you know what? That AI was totally different from AI of today. I used to work in Lisp language, LISP. Google it, and you will be just laughing your head out what Lisp was, and that was the AI of that time. But these days you don't even see Lisp language anywhere in AI, not at all. So I have reinvented. Sorry, I'm still reinventing myself. I'm still learning it. But if you ask from the experts of AI these days, they will tell you that it is still a very, very early journey in AI. So you are not late. You are never late, by the way. So if you're just starting out, take heart and then keep learning, keep exploring. I already have done around 3000 and almost 500 videos, or 3500, almost 3500 videos on the channel. You will find something to give you a kick start. Yes, that's a shameless promotion of my channel. So, but I believe that you can do it. So please subscribe to the channel and share it among your network, whoever is trying to get into this field. I'm sure that they will find something of interest. And there are a lot of other resources which you can search. Resources are there, learning material is there, everything is there. The only thing which is needed is your will to learn, to just hang on there, keep learning, and then keep inventing yourself and keep evolving with this field. Don't think that if you have learned something today, you are good with AI. This might become obsolete, and this is the way things are. This is what I was saying, that the rate of change has increased a lot. Earlier, when we learned cloud, it stayed for a while. But in AI, things are changing so fast, so fast. So keep learning, keep evolving. It could be frustrating, it could be very taxing, it could be very stressful, but quite rewarding, both mentally, socially, and hopefully financially too in the future. So that's it. I hope that you enjoyed it. Let me know what do you think about this. If you like the content, as I said, please consider subscribing to the channel, as it helps a lot. And please share it among your network, because I would be very, very grateful. Thanks for all the support, and thanks for watching.